We should be live. Let's go. All right, first thing I'll do is I'll go ahead and start some music. I actually just finished listening to the Color Splash soundtrack, so we're not going back to that. What's a good soundtrack? I know. I'll put the sun. All right, let me go ahead and um, go to the live stream panel here. Edit, playlist, stream archive. Oh, I forgot to hit stop recording. I am not recording this. I'm not filling up my hard drive with this. I need to go here. Share, copy. Alright, I'm gonna go ahead. I need to post the link. That is not the link. Why did it not give me the link? YouTube, why? I literally hit the share button on YouTube. Also, welcome to the stream, Mario Forest Studios. Glad you can make it. Thank you for joining us. Alright, so now I should be able to paste it in here. At Notification Squad. Alright, I've notified the Discord. So yeah, welcome everyone to the new game, or to back to the game. What I've been working on is making it so I can move stuff. Specifically making it so I can move individual vertices. Because Godot doesn't like that very much. I have gotten it to move some vertices. What the? Oh, yeah, that is actually intentional. I forgot that I already implemented that. Yeah, you can jump into the wall to rotate the world. Obviously, the world isn't rotating yet, and that is what we're going to be doing right now. Also, because this is not a mainstream game, I'm going to say that this is the soundtrack that I'm listening to now is the Fantastic Fist soundtrack by 100th Coin. Really cool game. You guys should check it out. Alright, so this is what I've been working on today. Fun. This rotate side method, where it basically takes a side and tries to rotate it. Or right now, it just tries to move the vertices. But one thing I have to do is I actually have to do this dumb shit with making a new mesh. Because it can only... The thing about it is I have to use a mesh data tool, but the mesh data tool only accepts array meshes, not normal meshes, because why would it do that? So I have to turn my normal mesh... I have to turn my normal mesh into an array mesh by doing this. But the problem is a mesh like this is actually three separate surfaces. The green surface, blue surface, and red surface. So so Godot, when you turn it into an array mesh, you can only turn one surface into an array mesh. So now I'm making it so it turns it into multiple meshes if it does that. So that's the fun part of what I'm doing right now. So what we should be able to do here is we should be able to say new mesh instance 3D. So we'll say mesh new equals, means that this is a mesh instance 3D. So we have a new mesh, or mesh new now, and we're going to add mesh new. But the reason we made it a variable is because we also want to actually add the mesh to it. So mesh new dot mesh equals mesh. So yeah, now what we can do is, also let me go back here. So now what we can do is we can get rid of you. And after we're done, we should be able to destroy the old. So we're going to say for each well, first I think I'm going to do this. If side dot meshes equals or dot length equals new meshes dot count, then I know that I haven't actually created any new meshes, so I should be able to just say each mesh is equal to its original mesh. So I should be able to say stuff like mesh new. Hold on a second. So yeah, I should be able to go ahead and say stuff like, wait, why is it mad? Oh, it's because this is a method. What? Is it not a method? Or does it count for, no, it should be length. No, but this is an array. It should be length. Why are you mad? Guess the total number of elements in all fit array. Oh, I'm using an if statement. For some reason I had single equal sign. Yeah, that'll do it. All right, so now we have the new mesh. So if it's the same, we can just go ahead and say for each actually no, we need to use a for statement. We can't use a for each because we need both of them to be on the same. All right, cool. And now what we can do is we can say sides. What? Side dot meshes mesh ID dot mesh equals new meshes mesh ID dot mesh. Otherwise, we need to basically make this real. So we're going to go ahead and say no. Stop. Did you remove it? Okay, good. All right, so what we need to do first is actually we need to remove each of these meshes in there. Side meshes at length plus mesh ID. That is correct. So now what we need to do is we need to queue free it. That'll destroy it. And then what we want to do is we want to go ahead and I guess we don't need to do anything else because that's just going to handle that. So now we can go down here and in mesh instance 3D, in a new meshes, we're going to say, or I guess we're going to go side dot add child mesh. All right. That should actually be it, I think. Add child node. I think that'll work. And then we should just be able to say side.meshes equals new meshes dot to array, and that should be good. I think the probability of this working is like 2%. Well, it did not work. Side test does have the array here. This is side test. I see. This doesn't have it in it. That will do it. Well, it did move part of it, but it didn't create all the other parts. So why did it decide to not do that? Surface ID, surface ID. Ah. Wait. Okay, I guess I can use Surface ID. Also, welcome to the stream, Horvath. Glad you can make it. Thank you for joining us. Or Aaron, I think I used to call you Aaron. It has been a while, for sure. Alright, so I think we can do it like this. Use Aaron. Man, feels good to be streaming again, I'll say that. Should be able to keep everything in here, actually. Alright, let's see if this works. How am I doing nowadays? Good, I have a job. It's cool being out of school, having a job, having fun, living my life. So now it's creating the, I think that is the last one. I think that's surface number 3. So yeah, this is the game jam that I'm working on. The theme is looping. What I'm doing is I'm making a 4-dimensional or 3-dimensional non-Euclidean game where you wrap around a tesseract and you have to like loop around it. It's gonna have all these gravity shenanigans and like you can, the floor is now the wall is now the ceiling, that sort of stuff. Right now though, I'm just trying to make it so Godot can actually see the wall. So yeah, why can it not do what I want it to do? Well, you're in a tesseract. Okay, let me go ahead and pull up paint. I should probably just leave this open because I think it's something that people should be able to understand if I have an image. So the best way I can describe it is give the two-dimensional example first. So if you have a person who's living on this box here, so you have a guy who's living on this box. He can go forward like this, and eventually he'll wrap back around onto himself. He'll be able to wrap around the box. Alternatively, if he went like downwards, he would go into the bottom side of the box, come up the back side of the box, then go this way across the top of the box, and then fall back down. So he's able to loop around it. It also means if you were to go like here, you go onto the next wall, and then you go down, you come back up the other side, you fall onto this face. If you were then able to walk on this face, you could then walk onto this wall like this. And you'd be on this side, like gravity would be facing this way. So that's the idea in 2 dimensions. However, in this game, you play as a cube inside of this cube. So you're a cube inside of this cube, where now you can go through this cube, and you'll basically enter the next tesseract, or the next side of the cube, which will then loop into itself. So you can basically continue on into this next cube, then to the adjacent cube, or opposite cube, then into the opposite adjacent cube, and then back into the original cube. So it's like the 2-dimensional example, but in 3D. I know I said I was going to save it, but I didn't. I just forgot. Let me see how many sides there are. Ah, I need to say print. As someone who loves the higher dimensions, I had to do it. Like, literally, this was the first thing that I thought of. Ah, debugger. Why is it having debugger? Stack trays. Oh. Index, P index equals 1 is out of bounds. Surface sizes equals 1. So yeah, why is it having trouble? Because it should be able to see it. Mesh. So it's weird. It's weird because it was able to see that there's 3 new meshes, which means it was able to get to the very last step here every single time. Which means, why is it throwing an error? Where is it even calling this from? It's from the mesh data tool. So I guess what's happening is it's right here. It's calling this right here where it's getting the mesh from the surface. Let's see if setting that back to 0 works. Oh, it just straight up works now. Okay. Cool. That is absolutely massive. That is like, that is what I was trying to do for this whole morning. I now have a piece of geometry that is moved. And what's cool about this is now the next part's easier, kind of. Now I actually have to do the stretching and projections, which is going to be fun. Okay. I mean, really all I need to know is where the vertex started, because then I know where it ended. How do I do this? I need some way of keeping track of where I started so that way I can do a full rotation. I think I'm actually going to do something a little bit different. I think I'm actually going to start off by separating the mesh inside of, instead of Game Manager, we're going to, that's actually problematic. Actually, no, it isn't. What we're going to do is we're going to make this private. Yes. And then we're going to make a bool, private bool. Meshes split. And now we're going to make a public get meshes. And it's going to return a array of meshes in 3Ds. All right. No need for any parentheses. And we're going to say false to you. What is the deadline for this project? Sunday at 1 p.m. It started yesterday at 1 p.m. So it's 4 days. And thankfully, I'm taking off work today. This is the first day I've willingly took off work. All the other times I've taken off work were either weekends or they've been mandated holidays. I'm trying to save up my time right now, but this is my first day off willingly. And it's fun. Yeah. If meshes split, at the end it'll return meshes, all right? And then here in Game Manager, we're actually going to go ahead and basically copy all this. We're not going to move necessarily everything over, but we're going to start by moving everything over. And here what we're going to do is we're going to say, all right, list new meshes, and then for each mesh instance here, for each side mesh, I don't think we really need to do any of this. Actually, I think I'm going to do that. So we don't need any of this here. Essentially what I'm doing is I'm doing a splitting step right here. So I guarantee the meshes are split. Because if the meshes are split, then I can guarantee know where they started. Because I don't have to worry, oh, they started here, but then it's split, and no, not having to worry about any of that. Nope, this is a 4-day game jam. So mesh new is going to equal new mesh instance 3D, new mesh. I'm not going to worry about this. I don't need to. I don't need else. All right. So now we have int mesh ID is less than so this will Q3 all of the meshes, and then we can go ahead and side.addChild what? So this can just be add child. So yeah, now we know that it's going to be guaranteed split in the correct direction. Oh, and obviously at the end of this, we need to set that meshes split is now true. Now I need to adjust the game manager. We don't have to worry about any of this anymore. We know that this is true because we split it. So we don't have to worry about this. It's great. Actually, we should just be able to put this inside of here. We don't even need a new mesh. Go here. We don't need a surface ID because we know it's going to be 0. So surface tool we need, mesh tool we need, surface tool create from side mesh. Yep. Right mesh is from that. Commit. Yep. And then we're going to edit it. Yep. Mesh, clear surfaces, commit to surface. So it actually should be just side mesh. This needs to be side.get meshes. You can also delete this here. What? I guess I have an extra parenthesis? I don't know how that happened. See, I don't need new meshes. I don't need a new mesh here. This should work, hopefully. Please don't break. Don't make me look like a fool. I don't want to look like a fool. Not like a clown. Yep, still works. And what's good about what I just did is now I don't have to worry about, oh, is it not split into different surfaces? Nope, it is. I now have confirmed that. Which means this can focus purely on transformations. Thank you, Aaron. At least until the camera is turned off. All right. So let's see. We got side mesh, surface tool. So now what we need to do is we need this to actually, instead of going just right, it needs to actually like adjust the vertex based off of, well, it's basically going to lerp it. Oh no. I mean, I guess this will work. It's a bit stupid, but it'll work. My idea is big brain. This should be a vector 3 mesh verts. Oh, I didn't realize. Oh, that's what it means. Okay. So now what we should be able to do is say public freeze verts. And the reason I'm doing it this way is freeze verts. What it will do is it will basically save the verts to this mesh verts field. So now what we can do is for each of these, and we will call get meshes here because we want to make sure the meshes are unsurfaced. I guess this should be a list. Yeah. Actually, I'm just gonna not have a constructor here because I want to put that in here. Mesh vertex add vertex, and yeah, that should work. Essentially, the purpose of freeze verts is so now I have a list of where all the verts start. I can basically freeze their position. All right, see Aaron, have a good one. So yeah, now what I'm going to do is I'm going to say side dot freeze verts. All right. And then it rotates the side. And what that does is now I can go over to side. Or I can go to game manager. Int vert height equals 0. So now here, instead of doing right times 20, I can do vertex equals this is a public thing. I guess I don't even need this vertex. Not really. Why do I need it? This is just where it is now. I don't care where it is now. I care where it started. This is going to be side mesh dot vert. Side mesh should be... Oh, that's a mesh instance 3D, okay. Mesh verts. Now, if there's multiple copies of the same vertex for each triangle, this should be fine still. Because each individual copy will be moved from its frozen position once. Yeah, I think this should be fine. This should be fine. There's going to be rotated vertex minus vertex. Alright, so that should lerp it. We can also rename vertex to frozen vertex. Cool. So now it should lerp. Obviously, if I'm doing set vertex to 1, it's going to be that. Let's say frozen vertex dot x dot z frozen vertex dot y. So what this should do is it should basically turn the z coordinate into the y coordinate. So basically this y component here should turn into the z component. It does not look changed. I'm surprised. I thought that would work. So that begs the question, why did it not work? Ah. Was that correct? No. So saying it has a null reference to freeze verts. What? Okay, that's weird. So it's saying when I try to add vertex, vertex is null. What? But I literally get it here. Vertex ID equals 0 while it's less than meshtool.get vertex count. Vertex equals mesh data tool get vertex vertex ID. Oh. Yeah. It's that mesh verts is not is null. Yeah, that'll do it. That will in fact do it. Maybe. And what do you know? It worked. They're rotated, baby. They rotated. The Z is now the Y. The Y is now the Z. Unfortunately, that's not that impressive, but it's very good. It's very good that that works. So now what we need to do is we need this rotated vertex to be the actual value. And what this is going to depend on is what your starting side is and what your ending side is. Or is it? Is this actually that complicated? After all, it should be a simple transformation to convert something into the center cube and then to turn it... I don't know. don't know. If I start inside and I go left, that's not that hard. If I go left, All right, I have to think about this because we're using a tesseract here. Here's where I actually have to do the different rotations. I mean, how many rotations are there? There's a lot. Because you have 8 different cubes, which means there's technically 56, well, kind of 56 rotations. Rotation 1 is going to be there to there. I mean, there's 56 different combinations. We don't need to care about all of them. I mean, we should only need to care about 48 of them, which isn't much better. Well, probably more than that, actually. Let's just start writing them out. Oh, you don't have a thing for current direction? Oh, why don't you stop lying? Well, if I'm rotating MX, MX is going to be the back. Which means it needs to be negative. Whatever, just make the switch statement. if I'm starting at X, if the player... So if I'm starting here, I'm starting on the positive X side. If the player moves right, then I'm going to be going to the outside. If the player moves left, or MX, then I'm going into the inside. If the player moves Y, oh shit. If the player moves Y or MY, I just rotate myself. Oh shit. Oh god. In that case, I'm still both in X, but I'm rotated now. I don't know. In that case, the whole target direction thing might not be valid. Because that's just gonna rotate it. Oh man. I didn't even think about rotation. Shit. Because yeah, this will just rotate this clockwise or counterclockwise, depending which way you go. It stays in the same location if you just move there. In that case, I don't think a target direction is right. I think a rotation direction makes more sense. So case. So in that case, we only have to worry about 6 different directions for each cube. No. Yes, that is right. So if I go in the X direction if I'm looking at the X cube and I go in the X direction, that's now going to become inside. All right, let's make a helper method for unwarping this cube, because the first step is to go ahead and take this cube the first thing to do is to take this cube and go ahead and take this side, you know, make it half as big. Extend this, and then we can go ahead and move it into the center. If we do that, then we can rewarp it. Then we can do whatever transformation we want to it, like say rotate it on the Z by 90. We can rotate it, and then we rewarp it the other way. So then we can rewarp it. But since we're going to be doing that a bunch, let's make an unwarp function and a rewarp function. Public or private vector free warp point So we need the warped vertex. For warping the vertex, we need the original vertex, and then we need the axis on which it's being warping. How do we warp this? I think what we assume is we are within the bounds. So I think first thing that we're going to do is we're going to turn this into an axis. Equals so in the case, it's going to be direction X. Then we're going to say direction axis is vector free dot right break case. We want to do dot mx next. Yep. Y direction axis is up. That's correct. My Z Well, hello there, Kanban. Glad you can make it. Thank you for joining us. I am, in fact, making a game from a game jam, and currently I'm trying to make a warping function to warp cubes into different shaped cubes. Currently, it does not work, so that is why I'm trying to make it work. So now that I have this, I should be able to say, I guess this should be its own thing. Ma'am, I don't care. I'm not going to do that right now. So now what I can do is I should be able to say, do I want to put it in a 1x1 cube? Or am I going to put it in a... I guess I should do it in a radius by radius cube, or a radius by radius by radius cube. So now what I should be able to do is, I know how far away I am. So it's warp vertex. In the X direction. Because I renamed that, that might actually have reverted. Nope, it saved it. Rotation direction is X. Yep. Yeah, I guess the outer cube is going to be twice as big. So vertex. Actually, we'll make a new one. Vector free. Warped. Vertex. Equals. New vector free. So, what we should be able to do is... Oh, wait. we'll start off by saying it's vertex. Next, we'll go ahead and, I mean, we should be able to essentially shrink one side of it. Or do we even need to shrink one side of it? No, we just need to grow the other side. So what we just need to do is we need to say basically your scale factor is based on how far to the right you are, or how far on that axis you are. And the way we should be able to do that is with a magnitude of that. So we can do a float warping factor equals new, or no, not new. The warping factor is going to be where the vertex is so it's going to be vertex times directional axis. No, because this is a matrix. I have to do each individual component, I think. Actually, we should be able to just do .x plus vertex dot y times directional axis dot y. So this is the warping factor. But we do need to divide each of these by, well, I guess we don't actually need to do that. We just need to divide the overall by the radius. Yeah, by the level radius. How big is the level radius here? I thought I set it to 40. No, the level radius here is 20. Okay, these are actually only 8 squares across, which would explain why it looks so weird. This is 8, this is 16, and this is probably 20. I see, I see. So by doing this, this will give me a value between 0 and, or from -1 to 1, essentially. So we can add 1 to this value. So now this should give us a value from 0 to 2. Make sure I have my parentheses. So now it's going to be a value from, now it needs to be 0.05 or 0.5 f. Okay, so warping factor, vector x is going to be some value from -20 to 20. Directional axis might be 1, might be 0. So this is a value from -20 to 20. All of these are -20 to 20. But the total is -20 to 20. That's the important part. Then we go ahead and divide this by 40. So now, -20 to 20, that's now a range from -0.05 or -0.5 to 0.5. You add 0.5 to that, now it's a value from 0 to 1. But if we add 1.5, now it's a value from 1 to 2, and that's actually what we want, surprisingly. Because we want to make it bigger from the unwarped cube. because what we're trying to make is this part of a tesseract. The standard size of the cube is the inner cube. We need this outer face to be bigger. We need it to be twice as big. So now we have this value that was negative 0.5 to 0.5. Now it's going to be a value from 1 to 2. So now what we can do is we can say take you, put you here. New vector free. Oh, and this does work with negative values as well, because this directional axis might be -1. So now we can say warped vertex is equal to new vector free. Shoot. Actually, no, that's fine. We can just scale the original vertex by that much, and then we can cancel out whatever we don't need. So this should be equal to vertex times warping factor. However, this would give us a cuboid result, I think. Would it? Yeah, because that's going to be 1 to 2. No, but it's still going to give us the cone, I think. But the cone is going to be... We want to not... We basically want the opposite of the direction. Wait, can we just do that? So that's the vertex times the warping factor. That's going to be a cube. Or, no, that's still going to be a cone. Wait. Oh, shoot. No, because the directional axis isn't going to change. And it has to be a value from 1 to 2. Essentially what this would give us, right here, this result, is the following. It would essentially give us this. I think it would give us this, actually. Yeah. This is the shape that it would currently be. All right, so I mean, I guess we could actually test this. Let's see what this looks like. Let's see what our arrows look like. Did I ever revert this? I did not. Yep, that's kind of what I was expecting. So you can see how it's larger on the X side than the minus X side. So now we need to figure out how to do that. No, I can't just like make an anti... I guess I can make just an anti-direction back. I guess this is the simplest way. So what about left? I think left should be the same as right. Because all I'm caring about is that. I think it should be that. I guess it would be perpendicular axis. All right, so now we have all these perpendicular axes. All right, so now that's all the perpendicular axes. So now what we can say is the warp vector, the warp vertex, so it's the vertex times the warping factor. So the x-axis is going to be, in this case, direction axis. So I think it's going to be something like this, plus, so whatever amount you're moving in the direction that you're going, plus whatever direction you're not going. So if x is the direction I'm going, so this value is going to be 1 or -1 or 0. All right, so direction x times vertex x, that could be two negative numbers times, or if vertex x is negative, well, it's just going to be vertex x. Unless direction axis x is negative. In which case we don't really want that to be flipped. So we're going to take the absolute value of this, I think. Because this is going to be 0 or 1. So now this is 0 or 1. So it's either on or it's off. And if it's on, we want to turn vertex x on. We want to move that. We want to use its vertex x. I think the first step is to divide vertex x by 2. Because that will give me the correct range that I'm looking for. Because the side of a tesseract is half as big as the normal cube. So that's the scaling. This is the movement. So I want to multiply that by 1.5. Because if a level radius is 20, I want it to be... Wait, no. I think it's actually 1.25 because this is going to be the center object. So 0 should be moved to 1.25. Then if x is not the direction I'm going, then I want this to be it times the warp factor. I think that's right. And now we just have to do that, but replace the values with y and z. Also, the music is over. I need to go ahead and start some new music. I don't know what I want to listen to next. Okay, but yeah, this should be correct. This should be correct. Let me start some new music and then we'll test. How about, I don't know. Yeah, I'll put on Twilight Princess OST. That's always a good one. All right, let's see. I don't know if this will work or not. I'm scared. I think it should work, but that doesn't mean it'll work. Doesn't matter what I think it should work. But that looks pretty good. That looks pretty good. Let's see how the box looks. That looks pretty good. That looks pretty dang good. It works, baby! Hell yeah! Oh my goodness. It works. Look at that. It's a cube. It's warped correctly. I've warped the cube. I warped the cube. I did it. So nice. The warping function works. I don't want to make the non-warping function. That's going to be a real pain in the ass. Let's not do that right now. Let's go ahead and add on some of these. See, thankfully all these cases of starting in the inner box are pretty easy. Oh wait, I just realized. Technically this should be the other way. Because if I start in the inner box, if the box I'm looking at is the inner box, and my rotation direction, or my direction is, yeah, my rotation direction is in the x direction, that means this should be moving away from me. So this should actually be going into the negative x, to the mx. So I was wrong, but that my logic still worked. Oh my goodness, it just works. It just works. Hell yeah. Actually, I should start off with mx here. Case direction dot y. If we go up, that previous cube needs to go down. Direction my. Warp vertex. So those were the easy ones. Yeah, now we need to unwarp the vertex. We will need the same direction axes. I guess going from inner to outer is technically something that can happen. I don't want to think about that. Because the way that would work is, how would that work? Basically, you'd need to flip and expand. Hold on. Would you need to flip every way? No. Okay. So how would I unwarp a vertex? Well, I guess we can add in this rule here. So here, well, inner will be the second to last. If we had case, direction, wait, I don't need parentheses around that. I don't need them around the switch cases. So around v direction dot x, which means I am going in v direction x, or if the box is in direction x. So in direction x, that means I need to unwarp it. So rotated vertex equals, yeah, it's just that. So this is going to be unwarped vertex. It's going to be frozen vertex. And this is going to be I think this should be direction x. Because unwarping a vertex is saying I take a vertex and what direction is that vertex currently in? I'm unwarping the x direction. So I think this is correct. So here, how can I unwarp? Wait, what? I didn't grab it all. Alright, so we can set that to unwarp. So now, what we need to do is, first of all, to get the warping factor, we again need to take u. So this is going to be a value from basically from, hold on. Yeah, 1.25. So this is going to be level radius to level radius times 1.5 away. We can use that. So if we take all the axes times their directional axis, so like let's say I'm looking at one that's in the x direction, you know, I'm looking at one that's in the x direction. I'm looking to unwarp a vertex there. I go ahead and add it all up. So now I'm left with a value from that's either going to be from negative level axis to level axis times 1.5, or I'm going to be left with a value from level axis to level axis times 1.5. So let's go ahead and first of all take the absolute value of this. So now, this value right here, this is going to be a value from level radius to level radius times 1.5. Which means if we divide this by level radius, it should give us a value from 0 to 1.5. So if we divide it by 1.5 times level radius, wait, no. Because if we just divide this by level radius, that's going to give us a value between 0 and 1.5, I think. Or is it from 0 to 0.5? No. This is going to give us a value from 1 to 1.5. And the reason it's going to give us a value from 0 or from 1 to 1.5 is because this is level radius. This right here, that is from level radius to level radius times 1.5. Divided level radius, you're left with 1 to 1.5. So from here, we have a value from 1 to 1.5. All we really need to do is first go ahead and subtract 1 from it. And that'll give us a value from 0 to 0.5, and then we just double it. And this will give us a value from 0 to 1. Cool. And now we need to basically turn this back into a value. Can we just turn this into times 0.2? Also, why did I use divide by 2 here instead of just times 0.5? Am I stupid? I mean, they're the same thing, but, like, division is slow. All right, so what we can do is, first of all, this is how stretched the direction axis is. So since we're unwarping it, it needs to be twice as big now. So yes, this needs to be times 2. But of course, no, that's fine. Because this was a value from, yeah. So now you're going to have a value that's between direction axis or level radius. If the value was level radius before, now it's going to be level radius times 2. So yeah, it's going to be level radius times 2. And this, and if you're at 1.5, now it's going to be level radius times 3. Yeah, same thing. So now we have a value from, wait, no, that's bad. Because when we times it by half, it was centered. No, that shouldn't do anything. Multiplying it by 2 should work. Oh, but it's half as big. What is the right answer? Well, before we were going from level radius to level radius divided by 2. Now we're going from level radius divided by 2 to level radius. No. Wait, are we? Oh no, we originally had level radius. Wait, no. We originally had level radius times 1.5. So if this was level radius, the maximum was level radius times 1.5. So now that we double it, I think if this stayed still, wait, would it be fine? Well, this is going to go to 2 level radius, and this is going to go to 3 level radius. Wait, no. My brain. The outer cube should be twice as big as the inner cube. And when you think about it that way, the direction axis times 0.5. So yeah, we shrunk it by half. Huh. All right, I'm back, and I actually remember to turn on the microphone now. All right, so this should be right. It should be, because this factor should be a value from 1 to 2. I mean, that doesn't even matter. We're not using the, are we? We're not using the warping factor here. Yeah, we only use the warping factor here. I mean, this feels weird, right? We're essentially saying move it 5 out. I mean, if the radius is 20, if we have a vertex at 20, it becomes 10. It's now from 10 to negative 10. And then we add on 20 to it. I think that's wrong. I feel like that's wrong. Because if we took a cube that's from there to there, yeah, you can see it's in the cube. You can see it's in the ground. Yeah, that is wrong. And I can probably go inside of it too, yeah. Because it's within bounds. I think only half of it is outside of bounds. Because that's going to be 20 large. And I only moved it 20 over. So part of it's still inside of bounds. So yeah. Okay. I was right. Something was off. And it's this. It needs to be level radius times 1.5. Because if a level radius is 20, then this needs to be level radius times... No, it is 1.5. Because we move it over 1, or we move it over 0.5, so that way it puts that there. We move it over 1 because that, yeah. Should be 1.5. The math is mathing, hopefully. It's hard to tell. Is it still inside? How is that possible? I'm right on the edge, but I'm clipped inside of it, I think. There we go. That's what I was looking for. I think it's right, actually. Oh, it's because of the player position. Yeah, it's right. The reason it looks off is because of the player position. The player position, when it goes out of bounds, that's when it triggers it. And it's technically still in bounds. That's what it is. See, I'm able to go on the edge of it because I'm technically still in bounds. So yeah, that is actually correct. Okay. I was a bit worried at first. But nope, I am right. I'm actually correct. Now for unwrapping this. So new vector free. So now we know that we have a value from, well, from radius to 2 radius. So now, if we go ahead and wait, why is this times 2? Oh wait, no, that is right. So yeah, now it's going to stretch from radius to 2 radius. Wait, no. It's going to stretch from 2 radius to 4 radius. So we're going to say times negative, probably 3, I think. And then perpendicular axis. And then it should actually be divided by warping factor, I think. Since the warping factor is going to be, you know, some value. It's going to be level radius minus 1 times 2. Yeah, I said this is a value from 0 to 1. Wait. Oh. It's not divide, but it isn't warping factor. It's 1 minus warping factor, I think. I don't think that's right, though. Yeah, I think I actually do have it wrong here. I think warping factor is wrong. Because this is going to be a value from 1 to 2. Yeah, this is going to be a value from 1 to 2 now. And since this is a value from 1 to 2, well, yeah. And what it should be is a value from 0.5 to 1. And right now it is growing as you get up farther away from it. That should be the opposite. So let's actually divide it by negative level radius. So now it's a value from -1 to -2. So if we add add 2 to it. Now it's a value from 0 to 1. So yeah, now it's a value from 0 to 1. So if we multiply that by 0.5, now it's a value from 0 to 0.5, which isn't what we want. We want it to be a little bit higher than that. We want it to be 0.5 higher, so we'll go ahead and add this by 3. So now, if we look at this is a value from level radius to level radius times 2. Then we get a value from 1 to 2, or from -1 to -2, plus 3. Now we have a value from 2, from 1 to 2, times 0.5. Now we have a value from 0.5 to 1. So that should be correct. All right, now we need to set these to y and z respectively. All right. Cool. So now if we look at the game, actually I don't have anywhere I use this. Um, so if I have trigger rotation, put that there. Direction dot none. Wait, no. What am I saying? Shit. How do I go ahead and tell it the direction that it's actually facing now? Because these are the directions it starts at. I guess we can just do this. Switch side dot rotation direction. Case. This is going to be direction dot right or x. Because we're starting from the inner direction, if you rotate x, that's going to be mx. If it's mx, then it's going to be x. If it's y, it's going to be my. If it's my, it's just going to be y. If it's z, then it's going to be mz. If it's mz, it's going to be um, z. And I think inner and outer should be special cases because it's impossible to rotate inner or outer. Yeah, that's just going to be inner. Cool. And then we have the side dot target direction. Give me the target direction. Don't tell me I don't have a target direction. Or no, it is rotation. I changed it to rotation direction. Equals direction dot none. Nice. So yeah. Now what we can do is during the physics process, um, if rotation time remaining is greater than 0, nah, I'm not going to change it. I was thinking about inverting it because this is counting down. I need something to count up. But I'm just going to do it manually. I don't care. It's not worth it to change it everywhere else. If rotation time remaining is greater than 1, then we decrease it. So now what we do is we say float rotation weight equals um, the time remaining. What? Did it really just say rotation time? This is what it suggested? Rotation time remaining divided by rotation time remaining? How freaking stupid is this thing? Yeah, it is called rotation time. So we divide that, and these should be both be floats, so that's fine. So now what we can do is we want to say 1 minus whatever this is. I'll say 1.0f just to be safe. Rotation weight. So yeah, that should give us the weight that we are in. Then we're going to say for each side in level sides, rotate side rotation weight. Also, before I trigger a rotation, I actually do want to do this. I want to say um, side dot freeze vert. Yep. And that should actually work. Maybe. I did a lot of coding there without a lot of testing, so I don't know. It might work. It very well might. Hey, let's go. Um, okay. That did something. Oh, because it's vector 0. Yeah, yeah, yeah. The only way I have it set up right now is if I enter it from here. But now that it's interior, it should work. No, it's only if I go X. It's only if I go X. That's the only way it works. That's why. Kind of worked. Not really. That's kind of weird. I think the issue is that I'm not setting it at the end. Yeah, that's what it is. That's what it is. Okay. That explains it. Yep. So what I need to do is here, if time remaining is less than 0, Then what I need to do is I need to, for each side and level sides, we need to say side. I guess we do need a switch statement here. Side dot rotation. We actually probably should make this its own method. Yeah. I'm gonna make its own thing. This can go right under rotate side. Private void finish rotate side. 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 And yep. Now I'll go ahead and call that finish rotate side. Side. And what this will do is it's basically just going to be a big switch statement. Switch side dot current direction side dot rotation direction. Is there like a double switch statement? That would make things so much easier. C# double switch statement. No, that's not what I want. I guess I could use tuples. I don't know. I'm not going to bother with it. I'm not going to try blowing this up. All right, so case direction.x. Switch. I actually don't want to use current direction. I want to use rotation direction. And after all that, break. So if my side direction is x, or if my current side direction is x, and my rotation direction is also x, in that case, I need to say that my current direction is now inner. Actually, I can do this programmatically. If switch, if side dot curse direction equals x, no, equals side dot curve direction or rotation direction, then I know that my current direction is now so like this is my side is on the x, and then my rotation direction is also x. That means I went x into this new pattern or into this new box. So now what I need to say is curve direction. So now I know that side dot curve direction equals direction dot inner. Um, I also, at the end of this, after I do all my if statements, I also want to say side dot rotation direction equals direction dot none. So yeah, I also know if my side direction so if I'm going x, um, shoot. No, no, no. Oh, I actually did something really, really smart. I'm really proud of myself. When I made the direction enum, I made none -1. I did not make none 0, which means I actually can use this pattern of them being even, odd, even, odd. I can use modulus or division. Wait, what is -1 divided by 2? And I'm not saying that like, oh, it's -0.5. I know that. But does it get truncated down or up? There's another print statement here. Where is it? Don't tell me there's not another one. We know there's another one. We know there's another one. Oh, is it in player? Is that where it is? No. Okay, where is it? I know there's another one. You can't tell me there's not another one. You can't tell me there's not another one. I know there's another one. I see it right here. You see this? 4? I know there's another one. Whatever. I'm just gonna write test here so I know about it. I mean, granted, this shouldn't really be an issue, but I want to make sure. It does truncate to 0. I don't think that's an issue, but it's something to keep in mind. Why is it printing 4? Oh, I do have a thing here. Okay. So yeah, now what I can do is I can say if side curve direction equals side direction, that's correct. Because the only ways that you can rotate are in the cardinal directions, up, down, left, right, BA start. Um, you can go in, if you go in a perpendicular direction, like if I'm looking at the X box and I go into Y direction, the X box rotates. to Xbox Live. God damn it. But it doesn't move. It's still an Xbox. That's important because if it's an Xbox, the only time it changes is if you move in the X direction, either in the X direction or negative. So I think I can say else if side dot current direction equals side dot what? Oh. Thankfully, they can if you just cast the enum to int. Then so else if, so now it's the opposite side. I know it's the opposite side. I can say side dot current direction equals direction dot outer. I think. So this works for all the outer cubes. Because if you're like MZ, well, if I moved in the Z direction, well now MZ is even farther away, it's going to be looping back around. So yeah, that is going to be outer. And MZ is one away from Z. Now the last thing that we have to check if side dot current direction equals inner, because obviously I'm not going straight to outer or anything. I can't transition into inner if I'm already in inner. There is no rotating inner besides the very specific case at the very beginning of the game where I'm just setting everything up. But that doesn't call this method, so I don't have to worry about that. So else if inner. If it's inner, then I need it to basically become whatever it isn't, whichever my rotation direction was. Direction or side dot current direction equals side dot rotation direction plus 1. Well, I don't know if it's 1 or negative 1. I guess if it's even or odd. Side dot rotation direction mod 2 so equal 0. So if I'm on an even number, then I need to add 1. Otherwise, it needs to be negative 1. And of course, this needs to be an int. It needs to behave like an int. Oh my goodness. I love ternary expressions. They're so fun and cool. But yeah, that should work. Um, I guess there's also the case if you're an outer. But in that case, you just become whatever the rotation direction was. Current direction equals direction dot outer side dot current direction equals side dot rotation direction. Because let's say I go in the x direction, well now the outer cube is the next is the next x cube. So that's actually really easy. Wow, that was so easy. I am lying. It was in fact not easy. I love being able to visualize the fourth dimension. So yeah, now if we go in here, you can see the cube envelops me. I proceed, it goes outside. Yeah, I don't have the other ones programmed in, but yeah, that's about what you would expect. Cool. Cool. I want to get a better view of it, make sure it actually did work. See if I zoom in, it unwarps it, and if I go up there, it rewarps it. See, I can go back out, and I did implement this, so it goes back to normal. And yeah, so it's able to warp and unwarp the world. Huh. It does appear that there's some glitchiness if you constantly do it. That's strange. That's really weird. Why is it doing that? Oh, it's probably because of delta. Delta can go to be less than 0. So if it's greater than 0, then you go ahead and subtract. And now it could be a value less than 0. So yeah, I'm actually going to go ahead and say if rotation time remaining is less than 0, then we're going to say rotation time remaining is 0. So now, if it is negative, it should be positive, or it should work still. I think that was the issue. Yeah, it seems to be behaving a lot better now. Look at it go! Look at it go! It's so cool! Oh, nope, it is still messing up a little bit. Oh. Yeah, I don't know. I don't know why it's messing up like that. I mean, that's really strange because it should be using the values. Like when you rotate from basically, I mean, I guess it is scaling it repeatedly. That's weird though. I'm guessing it's just due to floating point precision. I don't think there's much I can really do about this without like a major overhaul. Yeah, I don't know how to fix that, but I'm not going to care for right now. What I care about is the fact that it works. Let's go. I mean, did the box ever get bigger or smaller? I don't think it did. Because the box is at like 40 units. Yeah, I mean, like you see the box. Because the box is a cleaner model, it doesn't screw up as bad like the arrows do. Like you can see that the box is basically perfectly overlapping the ground still, like it should. Yeah, I mean, like there's the ground. You can see that it's basically a perfect overlap. I don't really get why the arrows are screwing up. Maybe it's because they're closer to the center? Maybe? I don't know. It's weird how they're getting stretched out like that, though. That's super weird. I don't know. So yeah, now we need to look at this. Rotate side. Close up, finish rotate side. Close up U, close up U. So, if I have the case, case MX, rotated vertex is going to equal the unwrapped. So this will have to cover the outer box. I guess in all of them I'm going to need the rotated vertex to be. I guess I'm going to start with unwrapping it every time. See, I can just go out here and say that this is just a normal thing that I do. Why is it mad at me? Oh, because I put it in the switch statement. Yeah, that'll do it. So you have a switch. Under the X case, it doesn't do anything. It's just the unwrapped vertex. So I can just remove that case. In the MX case, Let's make another method. Let's actually make it out here underneath these two because I'm going to have a warping and unwarping. Warp vertex outer. Vertex and then direction. All we really need to care about is we're going to basically multiply it by 2. We're going to have vector free, direction axis equals vector free, or yeah, equals vector free dot 0. Direction. Yeah, I know you're too stupid to know basic curly brace placement Visual Studio. Doesn't mean you have to be really stupid around me. Here the direction axis will be -1. Or what am I saying? It's going to be vector free dot left. Then we're going to do the same thing with y. All right. All right, this is going to be down, break. Then we have z, case, direction dot mz, back. Oh wait, no, we can't use this. Dang it. We actually have to make our own vectors. Because we needed these other spots to be 1. Alright, there we go. And bada boom, bada bing. We should be good. Oh, it's not going to be able to build. It's too stupid to know how to build. Also, I have an error, so there's that. The one who was too stupid to realize not to build was me. All right, looks good. And we can just make a copy of it for the unwarped version. I guess I could just make it like this. Then I don't need all the second two. If I just do it like this. Now I can just do that. Then here, for unwarped, we're going to have negative 0.5 F. All right. Pretty easy. What? Oh, because I built. That's why, isn't it? Yeah, that's what it was. Here it's foot rotated vertex. Now if it's MX, then it's going to be unwrapped vertex, and then it's going to be equals wrap or warp vertex outer. All right. So now it should turn inside out. Okay, I think we're good. So yeah. And if I go here, it should turn inside out. Yep. That is intentional. It works. We are now inside the cube. That should be what I want. So yeah, pretty cool. Pretty cool. And I think that should be how it works. Because when I rotate, If I rotate, I go into this block. That vertex becomes that vertex. And yeah, that gets pulled forward. I think I have this right. All right. I think I have it right. Oh wait, we can just remove this because we already have rotated vertex here. Why don't I stop being stupid? Let me think. All right. So we should be able to go like this. I mean, we should be able to rotate around an axis, right? I mean, we just need to take the point as a vector and then rotate it. Like here, the x, when you rotate it around the y, like if I go up, that's essentially the same as me going like this. I take this side, and then I go ahead and rotate it like this. Obviously, these edges would stay the same, would move as it moves, but it's the same idea. Wait, no. If I'm moving up, no, I am right. It would be like this because the edge on the left is originally the edge on the top, and I'm going into the top square, so that would make sense. So I'd be rotating on the y-axis, or in this case, the z-axis, 90 degrees counterclockwise. Rotated around the z-axis. And then the angle is going to be by 90 degrees. So pi and then it would go rotated vertex equals unwarp or warp vertex, and we're going to take rotated vertex, and we're going to be putting it in direction.x. Oh, I don't have a break statement in here. That's why it's yelling at me. Unfortunately, I don't have an easy way to test that. If I hide this, does it not appear in here? Or does it still appear? No, it does not appear in game. All right, let's see. Oh God, it's slippery. Probably because I have absolutely no friction. Let's try that. That should be easier to climb. I forgot to add back in the test box. So yeah, what should happen is this blue arrow, since I'm going into the top box, this green arrow should be pointing into the box. The red arrow should be pointing up. So yeah, the green arrow should be pointing up. Why is it not shrinking down when I do that? Okay. So blue is still pointing forward. Green is pointing downwards. Red is still pointing in, it looks like. I should be able to move around, actually. We turn on 3D, and we turn on the camera. Yeah, so green is down. Red is in. If we look at the start, green is up, red is back. So that essentially rotated it 180 degrees. Oh, I probably put math.pi, not math.pi. Yeah, that's probably what happened. Yeah, this needs to be pi divided by 2. We're doing a 90-degree rotation. Oh, I didn't save. Won't do me much good if I don't save. I think I have it backwards, unfortunately. Yeah, red is down. Red should be pointing up. Which makes sense because forward is backwards in this game. Engine. Forward is this way. So when I rotated it by 90 degrees, what I was doing was really doing this. I was bringing the outer edge up. Wait, that should still be correct, though. That should be correct. Wait. All right, what I am looking for is I want this side of the cube to rotate in this way. What once was up should now be right. Wait, no. It's the other way. I'm stupid. What once was up should now be left. What once was up should now be left. That's the best. If that is not what's happening, it's going the wrong way. What once was up should now be left. Right now, or into the cube. So the green arrow should be pointing into the cube after I activate it. And it's going the wrong way. Okay. I thought it was. That proves it. So if we go this way, now it should be correct. I don't know why it's doing that. When I go ahead and fall back down. I don't know what's going on anymore. Ah. Cool. Oh, these things still exist. Okay. Cool. It would stand to reason that going the other way would do the exact same thing in the opposite direction. If I'm the X cube, if that rotates me this way, then if I was on the bottom, then I would want my other edge to be going into the cube. So that should just be negative. I'm not going to test that because I would have to destroy the entire level. All right. So now we're going to have Z, which is a lot easier to test. If we go forward in the Z direction, that means I should be going... That means I need to be going rotated. Wait, what? Oh, yeah. So this is going to be up. best way to describe it is the forward, or I guess backwards, should be going out after this transformation. Wait, hold up. If that was forward, if that's going forward into Z, actually, I might be wrong. Because, yeah, if I'm going forward, I actually wanted to go this way, which means up should be going out. Or the inside should be, the pointing inside should now be pointing up or backwards. Down should be pointing in. What? That was weird. Why did that bring me in? Okay, something is broken. I don't know what is broken, but something sure is. Oh. Oh, and the reason why it's going to inside is because... Actually, that doesn't make sense. I mean, it kind of does, because inside is a 0. Or none is a 0. Alright, so if I go ahead and go this way... Yep. And I should be able to do this repeatedly. Yep. I can do it repeatedly. I think in order to prevent the sort of trippiness, I could go ahead and limit how many times you can transition over to Tesseracts. Yeah, I think that would work well. That makes it more puzzly. You have limited moves, and that would prevent it from screwing up. It would prevent you from having the visual glitches. I want to double check. It is going in the right direction, right? This forward arrow should be pointing inward. Yep, looks good. Cool. This is jank as hell, but it's cool. So that should handle all the directions. Because you have the direction you can go, the opposite direction, yeah. So I guess the next thing to do is have the different sides. So far we've done 2 sides. We've done 2 sides. 2 out of 8 cubes done. Thankfully the rest of them are significantly easier. Like, significantly. Let's start off by copying and pasting case X. Case MX. So now Um, so we're going to unwrap from direction MX. So we have direction X, rotated vertex, equals warp outer. All the warp outer. This is a warp. Yeah, all the warp outers don't matter for that. I can leave that as X. But I need these to go back out to MX. This might actually work. I don't know. I mean, it might. Wouldn't that be crazy if it just worked first try and it didn't break and explode and everything? So I go into this box. I go out of a box. And now I should be able to see, first of all, if I go back into the box, it obviously still works. I go back out of the box. So this should cause the blue arrow to face inward. It does. Now it should go back to facing down. It does. Going up should cause the green arrow to face upwards. Or inwards, I mean. So yeah, the green arrow needs to, when you go up, it should be going inwards. But yeah, the blue arrow is handling it right, I think. Yeah. So yeah, MY needs to be positive here and negative here. All right, there we go. So if we go up top, right now the green arrow is pointing upwards, so that's good. What we want is the green arrow should go face inward, and it does. And then it goes back up to facing at top because, yeah, that's right. All right. I mean, honestly, we could probably turn off the cube part of the side test. I don't know. No, that doesn't actually turn off the box. I thought it might. Did not. Alright, cool. So now we have 3 directions. You can go in 3 directions. That's so cool. Well, I guess, I mean, you can go in any direction, but like, now 3 of the faces work. 3 of the cubes. Oh my goodness. I think I'm gonna go grab some water really quickly. Give me a second. Woo! Alright, let's do the... We got, what? A dozen more? No, we only have 5 more directions to do. We are making very good progress, I'd say. Because with this system in place, it becomes significantly easier to manage. Alright, so we have Y. We're going to unwarp from Y. Switch side rotation direction. Case. I'm just going to leave it like this. So we'll call this MY. This will be X. And this will be MX. This is going to an outer, but it's going to be like that. That warps by Y. So here, this is probably not going to be forward. So this is if I'm hitting the top face. Well, no. This is if I'm hitting the X side. If I hit the X side, what does the top face do? Well, it actually should be rotated. If I hit the X side, the top face should be rotated on the forward axis. Okay, can I click the gosh darn platform now? Can I click the platform now? Can you let me see the platform, please? Please? Where's the thing? Why is it gone? What do you mean translate? Why am I translating it? Oh, it's on stupid mode. That's why it's translating, because it's on stupid mode, of course. Why didn't I think of that? I mean, it was pretty obvious that it was on stupid mode, right? Okay. All right, so let's see. So jumping to the X direction should cause the red arrow to point down. That wasn't very pointing down, in my opinion. I don't know why it shrunk to a speck of sand, but okay. Oh, is it because I went to MZ? No, that doesn't make sense. Thank you for that. So it's at Y. Now if I go in the X direction, it's still in Y. All right, the red arrows should point um, down right. So X is reversed, which means Y is, or yeah, that's also reversed. Z should point down. Z is completely screwed up, okay? All right, so the X directions are reversed. that needs to be positive, that needs to be negative. And for the z directions, they are completely screwed up. If I go down, no. If I go in the z direction, I'm going to be rotating on the x-axis. Change that to right, change that to right. So yeah, so the X arrow, if I go ahead and switch to 3D, switch to free cam. All right, so yeah, the red arrow is pointing that way. So the red arrow should start pointing down when I do this, which it looks like it is. It is cool. Now it's pointing that way. This should cause the blue arrow to rotate up. And this should, so that was reversed, so this is probably also going to be reversed. Yep. So these just need to be flipped, and then we're good. So this should cause the blue arrow to point down. It does. And this should cause it to go that way, yep. Can we do a full loop? That we can. Cool! Cool, cool, cool. That is the Z direct, or the Y direction. Now we have the most painful direction to test. The MY direction. I don't want to do the MY direction. The MY direction is going to suck. And I haven't even started looking at objects yet. Man, that's going to suck. These objects also have a gravity vector. I think I'm going to have to do objects because I have to have an exit point. But I guess I could just have like, I don't even know. I guess I could have cubes obey gravity. I don't know. It's going to be a pain in the ass, I say. So we're going to unwrap from MY. Unwrapped or wrap to MY for all these. these might work. Just depends on whether I'm lucky or not. So I would not get my hopes up. Oh wait, I'm just being dumb. I can literally just start it off on MY. I just started off, its rotation direction is MY. And now when I just test it, it should just start at MY. Oh wait, no, because I have to do it inversed. I have to start it at Y, and that'll start it at MY. So that actually works. The Z direction works. If I go in the X direction, first of all, the Z direction works because, wait, does it? No, the Z direction's backwards. Because it should be following the cube, it should be pulling backwards. So yeah, they're both backwards, but that's fine. That is a-okay. Wait, what? Oh, did I not build? I don't think I built. I did not. Yeah, if I don't build, it's not actually going to help. Cool. So now Z and MZ. So we have Z, then we have MZ here, then we'll have MY here, Y, MX, and X. And then these all need to be set to Z. Cool. So now, the last thing that I need to do is I need to actually tell it which directions to go. I need to give it the correct directions. Let's see which ones are built wrong. We should be able to just set this to MZ for testing. Alright, so if we jump into the X direction, it should move clockwise. Not that kind of clockwise, so that's the wrong axis. If I go into it, it should obviously... Okay. That was wrong. Let's try this again. So I think this is the issue. It's rotated in the Z here. This should, I said rotation direction is MZ. So it should be in the Z direction. But right now it's in the MZ direction. I mean, yeah, direction Z is forward. So it really thinks it's in the Z direction, but it's not going in the Z direction. Like if we go here, and we go ahead and we jump into or out of the thing. So we go in the X direction. It should tell us it thinks it's in Z. Yeah, it thinks it's in Z right now, but it's not. If it was in Z, it would be there. If I jump in the MZ direction, so I went into the MZ direction, and it went the opposite way. So it thinks Z is here. How? I don't get how it thinks that's the Z direction. Ah, there it is. Forward is back. Forward is a negative value. Why? Oh my god, what the hell? So up is 0, 1, 0. Down is 0, negative 1, 0. You know, the obvious thing that you would expect. Obviously. Right is 1, 0, 0. Left is negative 1, 0, 0. It all makes sense, except for forward and back, because of course forward is 0, 0, negative 1. Of course, obviously. Oh my goodness. That's so dumb. Well, that explains why this wasn't working either. Because forward's negative 1. So it's used here and rotate side. That's all fine. Okay, I don't think it broke too many things. But still, that's so annoying. What a dumb, idiotic decision to make forward -1. And like, I can kind of see it. The z-axis is weird, but still. Oh my god. So after a change like that, let's go ahead and build. So now it's in the right spot. Okay, well, something screwed up. Ah. Wait. But no, this should be fixed now. Oh, wait. Unwrap is probably still backwards. It is. Yep. Oh my god, what a stupid, idiotic, stupid decision. Alright, those work. Alright, if I jump there, the red arrow should point in. It is instead rotated, so it's the wrong axis. And if I jump down, this should bring the blue arrow should point. Wait. The red arrow should point away. It is not doing that, so they're both on the wrong axes. So those two work, obviously, those are easy. X, if I rotate around the x-axis, or if I go in the x direction, it should be going around the upwards axis. And if I am going in the y direction, then it should be rotating on the x-axis. I think that's correct. Alright, so blue should point away here. So that's reversed. And here, if I drop down, green should point away. And it does. Wait. No. If I fall down, green should point away now. Wait, should it? No, green should point in here. And it does. Alright, so it's just the Y that's screwed up. Alright. So if I go here, the red arrow should point inwards. If I fall down, the green arrow should go away. Cool. Looks pretty cool. And that leaves one more direction to go. MZ, negative Z. And the unwrap direction is going to be MZ. And the rewrap direction is going to be MZ as well. The to outer doesn't matter. And the rotation directions, I think, should be inversed, but I don't know. We can test that. All right, so if I rotate in the X direction, I should expect that face to face forward. It does not, so the X is backwards. If I jump into it, oh, that wasn't supposed to happen. Oh, maybe it was. Like, that's too big. Yeah, there's something wrong with that. It's not right. There's something wrong. I don't know what it is, though. But, like, you can easily tell that it's too big. Like, if I have it at MX and I jump into it, yeah, that's a normal size. Um, there's something up. There's something wrong. I can't tell what it is. I don't know. If I do it on MZ, does it still happen? No. If I have it on the normal Z, it works. Now it's on MZ, and I jump into it, and it says that it's inner, but it's really not. Oh, that's why. So now if I jump into you, that was dumb. Yeah, there we go. So if I jump here, that face should turn in. So that one's backwards. And if I fall, that should fall up. So that's also backwards. So they're both backwards. I thought they might be, but might as well check before I do anything dumb. Yep. Yep. All right. And then for the grand finale, if I go out, it then goes to outer, and we're good. And if I do anything in outer, it just shrinks to nothing because I haven't implemented it yet. Cool! That's really cool. Which means it's time for the last one. Case direction dot outer. Yeah, switch. Um, Side dot rotation direction. Rotation direction. Case. I mean, really. I mean, this one's actually pretty easy. I could probably do it programmatically, but I'm just going to do it like this. Make it easy. So unwarp vertex outer, frozen vertex. We should actually be able to take this out because we're always going to be unwarping it. Frozen vertex direction. I mean, that's just going to be the direction. Wait, no. I think this is the direction I am going. So yeah, this is just side dot rotation. rotation direction. So yep, then we have case direction X. Actually, I don't think I need this, because it's just going to be rotated vertex equals warp vertex. Because now that I have it unwarped, now I need to move it to the other side. It's going to be the next thing I enter. So it should just be side. No, first of all, I need the rotated vertex. And then I'm going to take direction, or side, dot rotated direction. Okay. Then break. So I think that works. So I have this. If I go away from it, it should become the outer. And then it becomes the inner again. Cool. It works! It works! Ha ha ha! Oh my goodness, you actually can build up infinite speed. Or you can start falling really fast. Man, it is really weird how it grows like that. Oh my goodness. That is good progress. Oh my goodness. Oh my goodness. My goodness gracious. Oh my goodness. We actually got it to work. You can now loop around the planet. The next step is significantly harder. Well, not really. It could be significantly harder. I really hope it isn't. I really want this to be nice and easy. That being, I want to add collision to this. Actually, I guess the next thing to do is allow inner and outer directions. So in here and ready, I need to say for each side. Whoops, wrong button. I was muted for too long there. All right, so yeah, so this is the next thing that we need to do. So yeah, we rotate to the side. So when we rotate, I guess we should rotate, um, so we should have special cases here. Well, we don't need a special case for inside because then it knows it's inside already. But if it's outside, I don't even know. I can't just pick a direction. So back to the old question of, what does this outer cube even look like? I mean, if I had an arrow pointing in the positive x direction, I had an arrow pointing in the positive x direction, it should be inverted. It should be pointing the negative direction. But whenever I pull it into the x dimension, it'll be that. So I think I do just make it -2, -2, -2. So I think this is literally just case direction dot outer. So rotated vertex will equal no. Rotated vertex equals frozen vertex times -1 or times -2, I guess. I think that's actually it. So first an inner text. What? Okay, the inner test did not work. I am surprised about that. Why did the inner test not work? Oh, because okay, I see. So we do need an inner case here because of vector free. All right, so now, Yeah, so now that works. Works just as you'd expect. And we try it on outer, it should start completely inverted. Yep, all arrows are pointing in the opposite direction. And if we continue in, now the Z direction is correct, but the other two are incorrect. So now if I fall downwards, now all the arrows are back to the way they started. If I go into 3D, I can show that. You can see how the blue arrow is forward, the red arrow is right, and the green arrow is up. Bit more stretched out than I would like, but you know, it is what it is. Cool. Let's do a little bit of organizing. We'll put player, player texture, player.blend, player scene, player texture, okay, sure. So now what I'm going to do is I'm going to make a glass side. Side tests can go in there. Test arrows, test. So now what I'm going to do is I'm going to say glass box. what we need here is a mesh instance 3D. And this is going to be a cube. Or a new box. And we want this to be 20 size. Inner rotation direction will be inner. Meshes, add one. That being this one. All right. And now what I want to do is I want to make a new material. And this will be called glass. All right. So now if we go back to the test scene, we'll go ahead and add in the glass. I don't think it recognized me. All right. Put the damn glass box. Okay. Put the glass box in now. All right. Why are you being retarded? Please. Oh, because this is the material, isn't it? Yeah. Why is it called TSCN for the scene? Just call it a frickin' scene. Oh wait, that's not gonna work because I need to actually assign it. Test. Game manager. Level size. Set that to 8. Glass. 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 There we go. Um, So let's have it be completely invisible. Let's first make sure this actually works. No. Okay. Oh no. Wait, no. I had a different material when I did that. You're not allowed to tell me that you're not allowed to remember the material. That's invisible. Have a tiny bit of transparency. Okay. Let's turn on the visibility for one of these. This is a true inner glass box, and it's gray. Why is it gray? That's very strange. It should be using the material. Also, I can go ahead and remove that comment down here. Okay. I mean, this is really weird because we already know that you can keep a material. Let's make a test material. Put it in test. Let's go ahead and give it some albedo. All right, let's see what that does. And it's completely white. Why? Oh, wait. But that doesn't make sense. I mean, maybe it's because... Is it really because my other one is an imported material? I mean, that's so weird. Why is it not able to see the material that it had? I don't know. So yeah, we'll just go ahead and make a material for this spin. Oh wait. When I saved test arrows, it made a copy of it. I think I can just delete that. Oh, it's the problem that the glass box here doesn't have access to the glass box inside of here. So that kind of works. There's no transparency. we want to do is we want to use external. Then we're going to go ahead and take you. All right, so now it's a Blender model. And it's using that material. And hey, we got it. Okay. Don't know why it decided that it didn't want to be there anymore, but okay. Okay then. Godot decided it wanted to stop working. All right, let's try that again. Ah, I did not like that. Hmm. All right. Now let's try it. And that's the effect I'm going for. There it is. And I'm trapped inside the ground again. Oh my goodness. Cool. Oh my goodness. This is like exactly what I wanted. This is so cool. I did it. I did it. I did what I wanted to do. I did the thing. Seems like it's holding up pretty well as well. You're inside of a tesseract, or you're inside of a cube, and you're transitioning between the different cubes of a tesseract. Oh man, I'm pretty proud of this. Even if I'm not able to finish a full game for this jam, even if it's not perfect, I am proud of this. This feels so cool. Like, look at it. You can go through the cube. You can see the cubes form before your eyes. All right, so now the next question, I guess, is can we turn off shadows for this, first of all? I don't know if I want to turn off shadows. Maybe it's part of this, the material. So now we have it on disable receive shadows, so now it should look a little bit different. I don't know. Oh man, it's just so cool. Having the cube actually, like having the tesseract actually rotate in front of your eyes, it's so cool. Oh man. You know, this has been like 12 hours of work, probably. No, more than that. Just to have a rotating tesseract. But now we can do things. I guess there are still a lot of steps, though. I think I'm done for right now, though. That's a really nice stopping place. Having an actual, like, movable tesseract or rotatable tesseract. So yeah, I think I'm gonna end it off here. I'll probably come back after dinner. So yeah, I'll see you guys later.